Hi, future doctors. Welcome to the next class. In this class, we will start motion in a plane. Motion in a plane. Till now, we discussed object is moving in one particular direction, either along positive x-axis, negative x-axis, positive y-axis, negative y-axis, or positive z-axis and negative z-axis. In this lesson, we will discuss object is moving in a plane. Plane means if you're watching on mobile screen is plane. It is having both x-axis and y-axis. If you are taking, isn't it? Otherwise, laptop screen. Laptop screen is also two-dimensional. Now, an object is moving from A to B like this. Whenever it is moving from A to B, it is going to cover some amount of distance along x-axis, some amount of distance along y-axis. This one only we will write it as x. This one only we will write it as y. This point B, or point A, we will write x comma y. Point P, this is A to P, x, y. This vector only we will call it as position vector. How we will write r bar means xi cap plus y j cap. For our convenience, this two-dimensional motion, we will divide into two one-dimensional motions. One-dimensional along x-axis, one-dimensional along y-axis. This 2D, two-dimensional, we will divide into two one-dimensional. One is along x-axis, y-axis. If it is YZ plane means along y-axis, z-axis, like that we will take. So now this is position vector of this object, whichever come moving from A to B, isn't it? Now this position is changing with respect to time. Let us assume from here, like this, like this, like this. At the time, along x-axis also its position is changing. If this position is changing with respect to time, dr bar by dt. So dx by dt I cap, dy by dt j cap. This one only we will write v bar is equal to vx I cap plus vy j cap. Like that, a bar how we will write ax I cap plus ay j cap. So till now we have written velocity in one direction, therefore v. But now onwards we will write two-dimensional vector. We will write like this. So now Vx horizontal component, Vy vertical component. A vector can be divided into two components. Already this one in basics we gave. A bar, if it is making some angle theta. Here also, if it is making some angle theta. Okay. Now if you resolve this one into two components, this is A cos theta, this is A sin theta. So this one we gave in basics. Again, I'm not going to discuss. A bar is equal to, we will write ax I cap plus ay j cap. So a cos theta I cap plus a sin theta j cap. This is going to be a bar. How vector can be resolved into two components. Ax is horizontal component for this, ay is vertical component. Same like this. These are the velocities position like this. Now this 2D, so one dimensional along x-axis, one dimensional along y-axis. If you are taking, how the equations of motion can be changed. We came to know three equations of motion. V is equal to u plus at. How we will write along x-axis means Vx equal to ux plus x. Along y-axis, Vy is equal to uy plus ayt. Now t will not be changed. Why? Because whenever object is moving from A to P, so x distance, y distance is different maybe, but time is going to be same, isn't it? Therefore, time we cannot write tx t. Next, what is the second equation? S is equal to ut plus half at square. This one only we will write sx equal to uxt plus half ay t square. Like that, sy is equal to uyt plus half ay t square. Next, v square minus u square equal to 2a bx square minus ux square equal to 2ax sx. Same like that. Vy square minus uy square equal to 2ay sy. Okay. This one only final equation generally we will write. How this vx, vy we will write means velocity in two dimensional is vx I cap plus vy j cap. Displacement s bar is equal to sx I cap plus sy j cap. Isn't it? Acceleration a bar is equal to ax I cap plus ay j cap. But on the acceleration on the surface of the ground, how we are going to take? On the surface of the ground, always acceleration. If you drop any object, object will be coming like this on the surface of the ground. Object will not move horizontally. Again, it will come downwards. Again, it will move some horizontal. It won't come like this horizontal. Therefore, acceleration is always along vertical direction, along y-axis. That may be positive y-axis or negative y-axis. Downwards means it is going to be negative y-axis. G minus j cap. So minus g j cap in vector notation. Now what is the horizontal acceleration? In horizontal acceleration for dropped object, it is always 0. There is no horizontal acceleration unless and until you are applying some amount of force in horizontal direction. This one we will discuss in our laws of motion. Till then, if the object is falling downwards or moving on the ground horizontally by projecting with some velocity, so always horizontal acceleration, generally we will take it as 0 because object will not move horizontal, isn't it? So acceleration is always, acceleration due to gravity is always downwards. Therefore, ax we will take 0. So this is about how we are going to divide equations of motion. So in this lesson also, you will get equations of motion only, but this variation will be coming like this along x-axis means along y-axis because it is moving in plane, isn't it? Now, in this mainly, we are going to discuss projectile motion. So what is projectile? So what is projectile means any object which is projected from the ground to ground projectile we will be discussing. Any object which is projected into air by making some angle theta with horizontal or vertical. Any object which is projected with some initial velocity by making some angle theta other than 90 degrees. So other than 90 degrees, because if it is going to become 90 degrees, it is going to become vertically projected body, which is making an angle theta with horizontal. This is u bar. If you resolve this u bar into two components, one is u cos theta, another one is u sin theta. Already we said about this resolution of a vector into two components. Now u bar can be written as ux I cap plus uy j cap in two dimensions. Ux equal to u cos theta I cap plus u sin theta j cap. After some amount of time, it is at point P. Now what is the velocity at this point P? The velocity after t time. So what is the velocity after t time formula? Along x-axis. Now v bar we will write vx I cap plus vy j cap. How we will write vx? Vx equal to ux plus ax. How we will write vy? Uy plus ay. Now vx equal to what is ux we wrote? Ux is u cos theta ax. There is no acceleration along horizontal. Therefore, Ax is 0. So therefore, Vx equal to u cos theta. Now what is Vy? Vy is equal to Uy is u sin theta. U sin theta. What is Ay means? Acceleration due to gravity will always act downwards. Therefore, for vertically projected body, u sin theta is vertical component. Therefore, minus gt. Now Vy, Vx you can substitute in this equation. Then what is V bar? V bar is equal to u cos theta I cap plus u sin theta minus gt j cap. This is the equation for velocity after t time. So they will ask what is the velocity after t time if it is projected with some angle. Then you have to use this one. If they're asking magnitude, how we will find? So magnitude of velocity is equal to root of u cos theta whole square plus u sin theta minus gt whole square. Now at point P, what is its position vector? What is its position of displacement? Now S bar or R bar is equal to so Sx I cap plus Sy j cap. Now what is Sx and Sy? So in this projectile motion at point P after t time, it is going to be, let us assume, S bar. Okay. Now what is this Sx? What is this Sy? Means Sx equal to what is our formula? Uxt plus of axt square. Sy means uyt plus of ayt square. So Sx I am taking it as, let us assume, x. X equal to what is ux we wrote already. See here, ux is going to be what we wrote ux. Ux is going to be u cos theta. U cos theta t. Ax is 0. Therefore, x equal to u cos theta t. That is equation. Now Sy. Sy I am taking this one as y. So y is equal to what is uy? U sin theta t. Ay is minus of gt square because u cos theta horizontal means u sin theta upwards. So call it as equation number 2. So we want x and y relation to say what is the path of this projectile. So generally we wrote displacement like this. If you want displacement, you can write like this. Magnitude also we can write. Modulus of s bar is equal to root of sx square plus sy square. Sx means equation 1. Sy means equation 2. So what is the path of this projectile? To say this path of the projectile, we want relation between y and x. Why? Because we came to know the nature. Y is equal to mx plus c. What is the nature of this straight line? X square by a square plus y square by b square equal to 1. What is the nature of this? This is going to be ellipse. Now, what is the relation between y and x? If you got, you will get what is the nature of this path. So now y is equal to u sin theta. To get x, we have to eliminate t. T is equal to, from equation 1, x by u cos theta. Substitute here. X by u cos theta minus half g into x square by u square cos square. Now, if you see this, u will be cancelled. Y is equal to tan theta x minus g by 2u square cos square theta x square. Now you can take tan theta as a, g by 2u square cos square theta as b, ax minus bx. Now this equation represents y is equal to ax plus or minus bx square represents parabola. Therefore, path of the projectile is parabola. In this, you have to remember this equation 1, 2, 3 for solving the problems. Understood? So Now, here how we have divided equations of motion in two directions. One is horizontal, vertical components. Here also, one dimensional along x-axis, along y-axis. Same equations of motion we will get, but along x-axis, y-axis. So velocity after t time, acceleration after t time. What is acceleration after t time means? A bar is equal to ax I cap plus ay j cap. Ax is 0, ay is minus j always, isn't it? Like this. Now what is the displacement after t time? This is the formula. Sx, Sy. Now what is the path of this projectile? Parabol. So from here, how they are going to ask the questions, we will see in our next